Okay, my 30 minutes are going to be on what NGS, my agency, the National Geodetic Survey, is going to do to everybody in 2022. Hopefully everybody's heard that we're going to have new datums, both horizontal and vertical. I'll be talking about that. My name is Scott Locken. I'm part of NGS's Regional Advisor Program. I represent the Mid-Atlantic region, so I have all the coastal states from Delaware down through Georgia, and they also included Puerto Rico and the U.S. Virgin Islands. So far I put in for travel there, and they haven't approved it in the last 2 years, but I'm working on it. If you need to get hold of me on any geodetic questions or surveying, that sort of stuff, you can go to our NGS homepage. There's a state advisor link. It'll bring you to this page, and you can click on my smiling face, and it'll bring up all my information, my phone numbers, emails, address, all that good stuff. So if you do have questions, I'm here to be a voice to NGS for you. So this is a required slide, I think, on every NGSer's presentations. But it really does. It defines what we do. Our mission is to define, maintain, and provide access to the National Spatial Reference System. So in essence, we tell you where you're at. We've been doing that for a long time. Since 1807, we've been telling you where you're at, for mapping products, for knowing where roads need to go, bridges. And when you see this slide over on the right-hand side, I've seen it in dozens upon dozens of GIS presentations. And normally they always have that control about 5 layers up and imageries at the bottom, right? You guys have all seen that one. But in essence, all that stuff is probably already referenced to the geodetic reference frame at some point. So that should be at the bottom of the list, whether it's aerial imagery that was orientated by GPS, that was probably tied to the National Spatial Reference System, what NGS does. So we tell you where you're at by giving you all the things: latitude, longitudes, northing, eastings, what gravity is doing, different elevations, how these things are all orientated. And what's becoming more and more important is how all these things change with respect to time, because we live on a dynamic Earth. So I got a few little questions for you. These are some of the challenges that NGS is having with the National Spatial Reference System. So how about this one? Which one do you think we're on? Of course, yeah, we're on the round Earth. We're on this great planet Earth. And actually, it's not a sphere either. It's actually a geoid. It has all these undulations and weirdness about it. So through the years, the way we've been able to define it, remember going back to NGS's missions, define, maintain, provide access, how do we define this geoid that we're all living on? How about this one? Are we on a dynamic Earth? Yeah, we all know. You have plate tectonics, things move. Out in California, those plates rub up against each other. You get earthquakes out of it. Other things happen. When the glaciers left North America, say up around Hudson Bay, there's a huge amount of mass that left there. It all made its way to the sea. So now you had a sea level change because all that water went in there, but you also have so that's a geometric change, but you also have a geopotential change because that mass moved somewhere. It left North America and ended up in the oceans. So now we have two different things that are happening. You might be having sea level change, but you also have a change in what gravity does, and gravity will always tell us where water is going to go. So those are challenges that NGS has to make. And then also, with changes up in Hudson Bay, when that mass left there, all of a sudden the Earth is now springing up still. So we have post-glacial isostatic rebound. And what's happening underneath there is gravity's changing. So all these things are happening, not just at the water's edge, but everywhere we have changes, both tectonic and geopotential. My next one is this lower species known as greater operators. Now, this may sound kind of silly, but in the past, NGS has provided access to the National Spatial Reference System. Remember those 3 things. Through monuments, those marks in the ground. Well, these greater operators, I think on question 5 of their operator test is, can you destroy a survey mark? And they all check yes. But that's a serious problem. In our database in the last 20 years, just the marks that have been reported recovered, 25% are not found. So how does NGS define this globe? How does NGS maintain access to these and maintain what's happening spatially when marks are disappearing, the Earth is moving, and our understanding of the Earth is all changing? So those are 3 big challenges that we have that we want to solve, or at least partially solve, with the 2022 datums. Hopefully you guys have heard about this. We're replacing NAD83 and NAVD88. We're moving to now where the primary access to these datums will be through GNSS technology. So that reliance on marks on the ground that are disappearing at an alarming rate is going to be lessened. We're also changing the NAD83, which was the best datum that we'd ever had in the States. But we missed where the center of Earth mass was by about 2 meters. So we're moving that to where it's truly on the center of the Earth. What does that mean? Well, since the satellite orbits, all this GPS, GLONASS, Galileo, Beidou, all those orbits are based on where the center of Earth mass is. So since we're offset by about 2 meters, every time you did a GPS measurement, somewhere in that software, it had to go from those GPS orbits to NAD83. So we're getting rid of that, so it should actually help GIS products that aren't having any connection to the ground through a real-time network or even through WAS, those things, to have a better, true to the datum position out of it. The vertical datum, that's for years and years we've done leveling, where you would start on one mark, move to the next, and it's all optical measurements. But now we're moving to where we'll use GPS to get to that vertical datum. And that's a little, we do it a lot right now, but many people don't understand that there's more things to it than just going out there with GPS. We need a geoid model to get from that ellipsoid height that GPS can measure to an orthometric height. And I think my next slide's on that. But we have a lot of stuff going on in NGS that will facilitate this. We're replacing our database, no small feat there. We're replacing the way we put things in the database so we can put more things in there, like point clouds. We have no way of inserting that in the database, but now we will have that in the future. We're redoing the state plane coordinate system. Gas, we're going to change the way those numbers are going to look at how some of the projections are around the country too. And we're improving our toolkit. We're going to make it easier for users to access the NSRS. Our new reference frames, hopefully you guys have seen these names. Somebody at NGS likes some really long names, I think. They just kind of roll off the tongue, don't they? So NAD83, the North American Datum 1983, will now become these 4 different terrestrial reference frames. In CONUS will be the North American Terrestrial Reference Frame of 2022, and each of the other ones for the Caribbean, Marianas, and the Pacific, they're all on individual plates. So since each plate moves individually, we need to have a reference frame for each plate. So now you're probably thinking, oh, we're going to have coordinates that move. Well, yes, we do have coordinates that move. You have it right now. You just don't see that. And that will be the same way in the future. We'll remove that tectonic motion that we have, the majority of it anyway, through a plate rotation model and another, what we're calling intraframe velocity model, to take care of those little changes. Like if you had an earthquake out in California and it jumped a centimeter, we'll have this other model that will take care of that incidental movement in there. So for some period of time, we'll have static coordinates. Whether it's 5 years, 10 years, hasn't been decided yet. The NAVD88, the vertical, like I said, will now be accessed through GNSS technology, and it'll be called the North American Pacific Geopotential Datum of 2022. I normally have to take a pretty big breath, but I've been doing a lot of talks lately, and I've built up my oxygen level so I can get that out in one sentence. But all these really do have a key thing in there. The names mean something. The geopotential datum, this is more than just a vertical datum. It also has gravity models built into it. So all these, it really tells us where water is going, where in the past, maybe the vertical didn't really tell us that, because you could have gravity doing odd things, and some of those heights differences at the small level would have been different. Let's see. So why change these things? Well, I've touched on that earlier, that non-geocentricity of the datum. We wanted to get that moved to where the true center of the Earth, where the scientific community was also saying it is, where the International Terrestrial Reference Frame is centered. So we'll align with that. Same thing that the actual satellite orbits are in WGS 84. That's actually aligned with the International Terrestrial Reference Frame at some point also. Then that dynamicism, how things are moving. We need to acknowledge movement and make sure we're taking care of that. Because there's places, southern Louisiana, that have a great deal of subsidence. Any mark we put in the ground is going to have troubles even a year later. It's not at the same place in three-dimensional space. With this mic, trying to keep my voice level down is really hard. So hopefully I won't blow you out here after a bit. So replacing NAD83, this is kind of a simplified concept on it. We're moving that center of Earth mass where we thought it was in 1983, the same place the international community, the same place the Department of Defense thought it was But we missed it. There's been decades of space geodesy, so now we're moving it to where it truly is. When we do that, we end up having to change latitudes and longitudes at some level, depending on where you're at on the globe. Here in North Carolina, we'll be moving about a meter horizontally. I think my next slide will show you that. It's kind of hard to see on this map, but you can see how this is a gradual change. So if we have a little over a meter of change horizontally, that since it's three-dimensional, there's also another part that's the ellipsoid height. So the rest of that's going to be an ellipsoid height. So when that's not to really think about like what NAVD 88 is. It's a different height called the ellipsoid height. But you'll be expecting to see around a meter, a little over a meter change in the 2022 datums. Ellipsoid heights, we'll be seeing about 1.2, 1.3 meters of elevation change in a downward direction. And the horizontal will be primarily in kind of north-northwest. Big key to doing the new vertical datum is that geoid model I talked about. Since we're going to base things on gravity and GPS technology, we need a new gravity-based geoid model. The current is one we call a hybrid, where we take a gravity model and warp it to fit what NAVD 88 is. And every time you do a survey, there's always errors in any survey that you ever do. We're very good at minimizing errors, but things crept into our adjustments. And we ended up with a problem that we want to correct. And we'll be doing that with this pure gravimetric geoid. We have a big program where we're flying gravity over every square foot of the U.S. so we can understand what the little gravity deviations are. Now, we could go out there with absolute gravimeters, they're $1 million at a crack. Even the cheaper ones are what, $500,000 plus a dedicated vehicle. Well, you can't get those out in the swamps. So with flying the gravity, we may not get quite the resolution of an absolute gravimeter, but we can get a whole lot more area, a whole lot quicker, and understand what the geoid undulations are. If you're ever out there GPSing, this is actually what you're doing. This is why we need the geoid model. If you're observing on the top of this hill, you're getting a latitude, longitude, and an ellipsoid height. That height above that mathematical surface that we define in our datum definition. But if you're wanting where water goes, you need to know where that geoid is. That best represents what a global mean sea level would be. So that's where that N comes in. That's where the geoid model is. And currently, when we warp it to fit, sometimes these things, it still makes NAVD 88, but it's not really referencing to what that geopotential at the geoid would be. So this is where we're heading in 2022 with the NAVD 2022. And I keep jumping ahead one slide when I give my talk here. Here's our name for it. We're replacing all these vertical datums. We have the Puerto Rico vertical datum of 02, the Virgin Islands, the different island datums, NAVD 88, the International Great Lakes datum. All these things will be replaced in 2022 by the NAVD 2022. Our geoid that I talked about is going to cover a third of the Earth's surface, going all the way from the equator up to the pole. We're including Greenland out to Hawaii, so everybody will be on a cohesive NAVD 2022. The expected heights shifts that you'll see, the new above sea levels, if you want to think of it that way. Here in North Carolina, we'll be looking at about a foot lower in elevation. If you get out all the way to the Pacific Northwest, you're going to see over a meter of change out there. Those are those little things that snuck into our adjustment. When we did the original NAVD 88, we held a point up here on the St. Lawrence Seaway called Father's Point Rimouski as the one point, and we held what the geopotential for mean sea level would have been at that point, and did the whole adjustment. Somewhere in the way here, we ended up with that meter of change in the Pacific Northwest. If we extend it all the way up into Alaska, it's over 2 meters. So that's going to be a big improvement for those guys that they'll actually be relative to the same heights. Excuse me. I did a little test here in Raleigh to see what these numbers were going to be. I took a course in there, calculated what the NAVD 88 would be with our current geoid 12B, and I also included what the NGVD 29 are. So you could see we started at a 85.324 with the 29, got a foot lower essentially with NAVD 88, and now we'll be moving about 9/10 lower for the NAVD 2022. A lot of this has to do with just the way we're picking what geopotential for those. When we constrained NGVD 29 is from 26 tide gauges, just that one on Father's Point. Rimouski for 88, and now we're just constraining to a gravity value that we'll be picking for NAVD 2022. We have different tools coming out. NCAT, the NGS Coordinate and Transformation tool, that's pretty powerful right now. It does a good job. I'm not sure how well it does on GIS products, but we'll be taking the math that we have behind here and giving out to the different vendors so they'll be able to incorporate our science into their products to have this transformation works. Currently, we can do single points. We can do multi-point files, but they're very particular on the input format. We'll actually have things available as a web service, so you can just call our web service in a routine instead of having to have the program. You can download it to your computer. It does a pretty neat job. You can go from all the way back to the U.S. standard datum and go through every different datum to 27, 83, 86, all the different realizations of NAD 83 that we had are available on there. And by the time we get to 2022, this will also be available for that. And we'll be including VertCon, the vertical end of it, into the tool later on this year, from what I've heard. If you guys want all the detailed information, the technical papers, we have 2 of them out there, blueprints 1 and 2, one on the geometric side, the horizontal, if you were, and one also on the geopotential, that vertical side. So you can go see all the thought processes that we had at NGS on what we're doing and why we're doing it. We have another blueprint coming out later this year I'm very anxious to see. This will be on how we use the modernized NSRS. How do we do leveling using GPS for control? So that'll be a key thing for me on my outreach efforts. If you want any more information on this, please go to our NGS homepage. I know 2 of us probably have it booked as our homepage in here, maybe more, I hope. If not, everybody should have it saved somewhere because it's a great resource. We have tons of different things. If you want to know more about new datums, we have a new datums page with a bunch of links. We have training on there. We have pages devoted to state plane coordinates, what we're doing with those. If you want to make state plane coordinates now, they're available. The geoid. We have a new geoid 18 that will be coming out later on this year, a new hybrid geoid. So that will be available. In fact, we had a webinar on it yesterday, and that's recorded on one of these pages. You go to our science and education, the drop down, and there's the webinar, so you'll be able to view that at your leisure. I kind of highlight this little link too, the subscribe to email notifications. We all get plenty of emails, but I really would encourage you, if you're interested in what's happening with new datums, anything that's happening with state plane coordinates, click on this. And we'll send you an email, probably 1 or 2 a month. If we have a new product coming out, we'll let you know. If there's an interesting webinar coming out, we'll let you know, like the one on geoids. We have one on state plane coordinates coming up on March 7th. So we'll remind you that's coming up. So there's a lot of great information here. My science and education tabs. Here's where you get all the other information. The webinar series down at the bottom. If you want to get hold of me, there's links on multiple places to the state advisors, and you can find us there. We have online lessons, and I'm sure you're thinking, man, geodesists doing online lessons. Well, we had smart people come up with lesson plans and gave it to a professional company that did the video. They're real short, 2-3 minutes, like a little YouTube, but they're very entertaining. We have ones describing datums, describing vertical datums, describing what we do with state plane coordinates, and this whole process that we're going through on the new datums. Any presentations we do like this one, I'll have that out in our presentation library. What my last thing to here is we're having a Geospatial Summit coming up in May, where we're bringing in the public to talk with us, and we'll speak with the public. So anybody can come to that and hear what we're going on and talk to us about it. This will also be available via webinar and a recorded webinar if you can't attend during those dates of May 6th and 7th. Webinars, the one yesterday, you can register for that. Here's the notice for the state plane coordinate system update by Michael Dennis. He's the man in charge of this new state plane coordinates 2022, and he's a very entertaining speaker. I would heartily suggest you register and listen into his presentation. And finally, on my Geospatial Summit, I had another slide on that. So May 6th or 7th, up in Silver Spring, Maryland, and it's also available via webinar. So that's all I have. Do we have any questions? Nothing? Wow. All right, well, I thank you for your time, and we'll have a little transfer time, and Gary Thompson will come up, and he'll talk about what's going to happen in North Carolina with respect to the new datums.